Hello everyone and welcome back to Explore Engineering. Have you ever wondered what happens when two different signals come together? In signal processing, combining signals is very common and important operation. One simple way to combine them is by adding their corresponding samples. In this video, we are going to understand the addition of two signals using MATLAB. We'll take two signals, add them sample by sample, and then visualize the original signals along with the resulting signal using MATLAB plots. So open your laptop, write the program step by step and see how two individual signals combine to produce a new signal. Let's get started. So before going to addition, we'll see what are the different operations which we are performing on the signals. So these are the operations on signals in DSP, that is addition, multiplication, scaling, shifting, folding, which is also called as time reversal. In digital signal processing, operations on signals help us understand, analyze, and manipulate the signals for various applications. First is addition, which combines two or more signals. Next comes the multiplication, where we'll multiply two signals point by point. Then comes the scaling, where we are multiplying a signal by a constant. Then comes the shifting. Here it is advancing or delaying a signal in time. You may either right shift or left shift the signal here. Next is the folding, which is also called as the time reversal, where there is a reversing of a signal in time around n is equal to 0. So here these are the different operations. These are the mathematical equations which define these equations, these operations, and here these are the signals, okay, which we have taken. That is, here we have taken x1 and x2 to add, and this is the resultant signal. Similarly, here you have x1 and x2, we are multiplying this. This is x1, this is x2, we are multiplying, and where we are getting the output here, y of n. Then you have scaling. Similarly, for scaling, you take only one signal and you multiply it by a scalar. That is, it may be any constant. So you get here y of n, where the amplitude will be increased by the factor a. Then you have y of n, which is x of n minus n naught. Here you will be shifting the signal. Okay, you may either right shift or you may either left shift. Then comes the folding, where here y of n is equal to x of minus n. Okay. Now in this video we will see only the addition operation, whereas these operations we'll see in the subsequent videos. So let's get started with addition. Addition is the process of combining two discrete time signals by adding their corresponding samples, that is the elements, at the same time index, and the resulting signal has a value equal to the sum of the two input signals at each sample. And here this is the mathematical representation of the signal addition, that is x1 of n plus x2 of n. x1 of n is first input signal, x2 of n is the second input signal, and y of n is the output signal after addition. Now here you can see in signal addition what happens is the amplitudes of the two signals are added sample by sample. Now here at sample, we are taking the sample index from 0 to 3. Okay. At 0, x1 is 2. Here you can see at 0, x1 is 2 and x2 is 1. Okay, so we will add this 2 plus 1, 3. So this is the resultant signal, where we get at 0 the signal, that is the resultant signal. Here it is 3 at n is equal to 0. Similarly, x1 at n is equal to 1 is 3. Then x2 at n is equal to 1 is 2. When you add these two, you get 5 here at n is equal to 1 at y of n. Similarly, for n is equal to 2 and n is equal to 3, that is 2 plus 2, you are getting it as here 4. Then here it is 0 plus 2. Okay, 0 plus 2, you are getting it as 3. Now comes the program here. As usual, the program starts with the three basic commands, that is CLC, clear all and close all. CLC stands for the clear command window. It removes all previously displayed text from the MATLAB command window, and this provides a clean screen before running the program. Next, second is the clear all, which removes all variables stored in the MATLAB memory, and it prevents the previous variables from affecting the current program, and it ensures that the program starts with a fresh workspace. Then you have close all, which will close all the figure windows, that is the all previously opened figure windows, and it ensures that only the current graph is displayed. Then you have n is equal to minus 10 colon 10, which creates the time index n, and the sequence starts from minus 10 to plus 10. Okay, and the samples the generated samples like sample indices are from n is equal to minus 10 to n is equal to plus 10. So a total of 21 samples sample points are created here, that is including 0 also you have. Next you have x1 is equal to sine of 0.2 into pi into n. So here it will generate the first discrete time sinusoidal signal using the sine function, and this is the mathematical equation where the 0.2 pi is the angular frequency in the radian per sample, and n is the discrete time index. So this MATLAB will calculate the sine value at every sample of n. Next you have x2. x2 is equal to cos 0.2 pi into n, which will generate the second discrete time sinusoidal signal using the cosine function, and this is the mathematical equation here. So both signals have the same frequency but differ in the phase, okay, because one is sine and another is cosine. Both are phase shifted versions of each other. Now next you have y underscore add, that is equal to x1 plus x2, where we perform the signal addition. So here the corresponding samples of x1 and x2 are added. Then for like next you have stem. Okay, so that is you need to plot the output signal. For that we are using stem n comma y underscore add comma filled. So here the stem function, it plots the signal as a discrete time sequence. Here we are getting it as discrete time sequence. Then here n is plotted against what n is plotted in the x-axis, and y is plotted in amplitude is plotted on the y-axis, that is y addition. That is the addition of the two signals, that is y underscore add, it is on the y-axis. And this filled, okay, filled fills the circular markers. Here you have the circular markers. No, this is for this is because of this filled. It will make the graph clearer and more attractive. Then you have here the graph displays only the resultant signal after the addition. Now next what we need to add, we need to add the title to the graph. So for that we are using the title A, okay, A signal addition. Okay, signal addition. You can remove A also, you can put just signal addition. Then you have label, x label and y label, in order to label the x-axis and the y-axis. So here this will label the horizontal axis and this will label the vertical axis. Okay, now you have grid on, so it displays the horizontal and vertical grid lines. These square boxes are there, no gray color lines. This is because of the grid on. Again, this makes it easier to read the amplitude and sample values from the graph. Okay, so next, this is another program. Here again it starts from the three basic that is commands. Okay, so here what we are doing is in previous program we have taken the signal, but here we will give the signal of our choice. Okay, in this program we have taken a sine and cosine signals, two signals x1 and x2, but here we will enter the signal of our choice. So because of which we have taken x1 is equal to input, enter the first signal x1 of n as vector, where we will enter the first signal. Similarly x2 is for the second signal. Now what we have to do is we have to check whether both the signals have the same length or no. If they are not of same length, then we'll get the error. So for that you have to use this condition: if length of x1 is not equal to length of x2, then it has to display error that both the signal must have the same length, or else it has to generate the sample index. It is 0 is colon length of x1 minus 1. Okay. So here next is what? You have to perform the signal addition, and here comes the plotting of the signal. So first is the subplot 3 comma 1 comma 3, that is there are 3 rows. Okay, 3 rows. This is the first column, and this is the first position in the 3 rows. Okay. Next stem n comma x1 comma field, then title, x label, y label, and grid on. Similarly for other two you have to do subplot 3 comma 1 comma 2. Okay, here this is for the second signal. Then subplot 3 comma 1 comma 3, this is for the third signal. Now display the output signal. You have to, it must display the output signal as disp resultant signal y of n. So disp y end. Now here you will get the output like this. Okay, here what you have to do, you have to enter the first signal x1 of n as a vector, that is 2 3 1 0. Okay, you have to put square bracket, otherwise you will get error. Then enter the second signal x2 of n as a vector, 1 square bracket 1 space 2 space 4 space 2, and close the square bracket. Now you have to check whether you have written or you have taken the signals of equal length or no. Here the signal length is 4, 1 2 3 4, 1 2 3 4, so you will not get an error. Now here this is the first signal, what it is, 2 3 1 0, so it is 2, then you have at 1 you have 3, then at 2 you have 1, at 3 you have 0. Similarly this is the second signal, and this is the addition of both the signals. So if you add this, this is the resultant signal. This how we'll get here, this will be displayed for this. Okay, here display the output signal disp resultant signal y of n, like this. Okay, so here this is the addition of the two signals. At 0 what you have got, 3. Okay, 3. At 1 it is 5, at 2 also it is 5, at 3 it is 2. Fine. Now here these are the applications of the addition, that is addition is used to combine two or more signals by adding their corresponding samples. So first is combining the signals from different sources. You take source 1 and source 2 and you need to add these two, you will get the resultant signal. So here the signals which are received from the different sources are added together to produce a single combined signal. Next, it can be used for audio signal mixing, that is you can take a vocal, then here you can take a music, and you can add these two to get the mixed audio, that is different audio signals. One is vocal, one is music. These two can be added in order to create a final mixed audio output. Next, you have image processing. You can take two images and you can get a combined image for that. Okay, so here the images are added pixel by pixel in order to obtain a combined or enhanced image. Then comes the signal enhancement, where you will take the original signal and enhancement signal, you will add these two and you will get the enhanced signal. Next, this will signal enhancement, it will improve the quality, reduce the noise, and enhance the features. Then you have digital communication systems. So here if you are having two messages, message 1 and message 2, that is message signal 1 and message signal 2, if you add these two you will get this signal, and this will be the transmitted signal here. Okay, so this is called as multiplexing. Multiple digital signals are added, for example multiplexing, in order to transmit the data efficiently over a single channel. So addition of signals is fundamental operation which is used in various real world applications in order to combine, improve, and transmit the information efficiently. Okay, this is the difference between the two programs what we have used. First is the predefined signal, because here directly we are using x1 of n as a sine signal and second x2 of n as a cosine signal. Now here it is less flexible because the signal cannot be changed without editing the code. You have to edit the code in order to change the signals. Here there is no user input required. Okay, and the length of the sample set is fixed here, whereas here the length depends on the number of elements which are entered by the user. And here the sample index is from -10 to +10. Here the sample index is generated automatically based upon the signal strength, signal length. Then here there is no need for checking because both signals are predefined, that is both are of equal length, whereas here we need to check for the length of the signal. Next you have output, displays only the resultant signal here, whereas it displays the first signal, second signal and the third signal. Okay, then you have applications. This is used in demonstrating the addition of predefined sinusoidal signals, and here this program is used for performing addition on any discrete time sequences entered by the user. So here this program 2 is user defined signal. Here the signals are entered by the user during the execution, and it uses any discrete time sequences entered by the user. You can enter any numbers, and it is more flexible because different signals can be tested without modifying the program. And here the user enters the values of both signals from the keyboard. Okay, so this is the difference between the two MATLAB programs which we have used for signal addition. Now we'll see the execution. So I will take the first program here, copy, and already I have typed here in the Word file, so I will copy this directly, and I have already opened the MATLAB window software. So here in the editor window you need to type your program. I'm pasting the program. You need to type your program. Okay, now run it. Oh, I'm not getting. I will save this on desktop. I'll create a window here, new window. Sorry, new folder. MATLAB programs. I will save in this. Okay, now run. I will close it. Okay, I will open the MATLAB once again. Already this is pasted. Now I'll run it. See, this is the resultant signal. Okay, that is the signal addition. Okay, this is how you get the first one. Now we'll go for the second one, second program, where we'll enter the values for the signal. I will paste here only. Now run. See, here you are getting in the command window, enter the first signal. Put a square bracket, 1 space 2 space 3 space 4. Okay, second one, I'll enter the same, 1 2 3 4. What you should get? You should get 2 4 6 8 after addition. Okay, see, here you are getting 2 4 6 8 after addition. So here it is 2, it is 4, 6 and 8. These are the two programs for signal addition. One is with user input and another is with predefined input. I hope you have enjoyed the video. So you can try for different values of signals here for the second program. Okay, so and that's how we add two signals using MATLAB, and by adding their corresponding samples we obtain the resultant signal. Okay, so keep experimenting with different signals and let MATLAB make signal processing more interesting. Thank you for watching and keep learning.